Thank you, Brian, for the introduction, and also to Brian Uzi for inviting me here. It's a pleasure to be here. I'd like to begin with a video clip that went viral in the 2004 election.
What do you think of Howard Dean's plans to raise taxes on families by $1,900 a year?
What do I think? Well, I think Howard Dean should take his tax hiking, government expanding, latte drinking, sushi eating, Volvo driving, New York Times reading,
body piercing, Hollywood loving, left wing freak show back to Vermont, where it belongs.
Got it?
Club for Growth PAC is responsible for the content of this advertisement.
So these associations between politics and lifestyle are certainly amusing, but they also pose. Mike, I think it's on. Green light. Can I turn it up? Maybe move it up? Is that better? I'll talk loud as well. Can you hear me? They can't hear me, so they... How's that? Better? In the back, raise your hand if you can hear me. Okay. So this puzzle has been addressed by social scientists, and the standard procedure in those efforts is to look for answers using survey data and a multivariate linear model. Typically, the explanations tend to look for ways in which individuals' interests and their personal experiences would shape their attitudes and their behaviors. But buried deep inside this standard methodology is a rather curious assumption about where opinions come from. The general linear model assumes that observations are independent and identically distributed, and random sampling creates independent observations. And it's as if everyone lives on a deserted island. Their opinions are shaped by their individual interests and experiences without regard to what anyone around them is thinking. But the problem is that people are not independent in the underlying population that the sample is intended to represent. The underlying population is characterized by network autocorrelation that's caused by a self-reinforcing dynamic of homophily and influence in which similar people are prone to interact, and interaction promotes similarity. So we now have two explanatory strategies for understanding where opinions come from. The prevailing strategy is to look for within-me mechanisms. For example, Stephen Colbert might point out that liberals love lattes because they hate America and they love anything that's foreign. But the alternative approach is between us rather than within me, the dynamics of homophily and influence. And the problem is that data from random samples gives us no way to distinguish these mechanisms. What we need to do that is network data at a population scale with rich measures of political opinion and demographic profiles. And until that becomes widely accessible, and I think that's happening, and we saw some of that today in both James' talk and Lattes, but until that becomes widely accessible, an alternative solution is to use simulation, and that's what we did. First, we simulate opinion dynamics generated by homophily and influence, and then use survey data to see if the observed patterns correspond to those predicted by the model. So the model has up to 10 static dimensions that correspond to demographic traits and 10 dynamic dimensions that correspond to issues about which people might have opinions that they could change. And these dimensions have up to 10 values on each dimension. We assume a network of 100 nodes that would correspond to a large group or a small community. And we use an EARN model of social influence. And here's a conceptual representation of how the model works. The focal actor likes the latte drinker, even though they disagree about beverages, because they agree on music and politics. So she gets 8 votes. And the two men agree on beer, but they disagree on politics and music. So he only gets 2 votes. The wine drinker gets 6 votes, but because she's an outgroup member, the relationship is negative, the wines get flipped randomly to beer and lattes, and then he picks from the urn, and lo and behold, he picks a latte. So now his attraction to the fellow latte drinker increases because they now have an additional dimension of similarity. His relationship with the wine drinker is unchanged, and his relationship with the beer drinker deteriorates. So that's pretty much how the model works. More formally, we initialize the model with dimensions that are randomized in the unit interval, and then from these dimensions, we compute the Euclidean distance between pairs of nodes, and from the Euclidean distances, we derive the edge weights as the difference between the expected and observed distances. So the weights can be positive or negative. And for the influence function, the probability of a ball with J's trait or opinion on it going into the urn is a function of the square of the edge weight, and the value on that ball is flipped if the weight is negative. And finally, the model also permits a parameter to vary the within-me effect from 0 to 1. And I'm going to start out talking about results where there is 0 within effect. We look at 2 outcomes, the correlation among dimensions and the energy that's trapped in the network, which is simply the sum over all the node pairs and all the dimensions of the pairwise distances on the dimension multiplied by the edge weight. So the idea is that energy increases when nodes disagree with their in-group members and agree with their out-group members, or out-group neighbors. So here's a stylized example to show you how energy can be trapped in a network. Issue 4 is causing dissonance in the network because of disagreement with in-group members and agreement with out-group members. But the problem is that changing your opinion on issue 4 to resolve the dissonance will simply increase dissonance somewhere else. So this is in fact a local minimum. It's a local energy minimum, and it's stuck there. Except maybe there's a random perturbation. And it causes node I to flip the position on issue 4 to go from blue to red. And this can trigger a cascade, which allows the system to shed some of the energy to arrive at a lower local energy minimum, or in this case, we're going to see it actually goes to the global minimum. The change in agreement leads to a change in the edge weights, and then to further changes in opinions, and then again in the edge weights, and again in the opinions, until the system arrives at a 0 energy configuration, or it could have gotten trapped in another but lower local energy minimum. So I'm not sure if you're going to be able to see this with, yeah, you can kind of see it. So this shows the model dynamics from a random start in a simple case in which there's one fixed dimension, or static dimension. At equilibrium, there is 0 energy. All the blues agree with each other and disagree with all the reds, who all agree with each other. So all the issues now are perfectly correlated. R's are 1.0. Interestingly, though, on the next run, what could happen very easily is that the opinions will switch. So maybe this time it's the blues that drink lattes. Next time we run it, it might be the reds that drink lattes. But it will still be the case that all the blues will agree with each other and disagree with all the reds. The problem is that a blue in this model lives only in that world and has no way to realize that in other runs of the model, the positions might be switched. And so the blue assumes that this is a real correlation and then looks for within-me explanations to make sense of it. When in fact, it's nothing more than the dynamics of homophily and influence, because we've turned off all the within-me effect. Now, as we add more dimensions, the outcomes are less polarized, and the correlations are generally smaller. More precisely, the number of dimensions has a non-monotone effect, as you see here. Notice the bifurcation at low dimensionality. Low-dimensional spaces are more prone to becoming jammed in high-energy equilibria, which we see when we superimpose the energy distribution. And what we see here is that the size of the attribute space, the number of dimensions, has two effects. First, the smaller the opinion space, holding n constant, the greater the density of any given opinion profile, more people in that profile, which increases its attraction, and it allows the network to be trapped in a high-energy equilibrium. On the other hand, low dimensionality also allows opinions to load up on a single fixed dimension, which allows those opinions to all be correlated with each other, giving a high correlation. And that's what we see in the upper left. Conversely, as the number of dimensions increases, the density decreases, but only to a point, because once the profiles are empty, further increases in the number of dimensions does not contribute to that effect, but it does increase the number of opportunities for opinions to load up on orthogonal fixed dimensions, which then traps more energy in the network. So that's how you get the non-monotone effect. So far, we have assumed a world with zero within-me effects. Now let's relax that assumption and introduce some small amount of within the individual effect, something that is more like what we would typically see in a social science explanation. So that now there's going to be something about being a liberal that makes you drink lattes, or maybe it's the other way around. There's something in the lattes that causes you to be liberal. So here what we see is this line is showing what we should observe if there is zero network autocorrelation. We should see the ground truth of the amount of within individual effect that we have allowed in the model. But in fact, there is network autocorrelation, and what we actually observe is an exaggeration of the within-me effect, especially at very low levels. So the slightest little epsilon amount of within-me effect gets highly amplified and exaggerated by network autocorrelation. So to sum up, the model makes two predictions. With zero within-me effects, any randomly chosen opinion is likely to be correlated with other opinions and with demographic dimensions. So it's a very correlated world. And with very small within-me effects, these effects become highly amplified. So the question is this what we observe in the empirical world? To find out, we data mined nearly 4 decades of opinion surveys with a cumulative N of over 55,000 respondents, with thousands of issues on a wide range of topics: social, economic, political, lifestyle, as well as 8 demographic measures which are difficult or slow to change, so not so susceptible to influence. And what we observed corresponds with the model predictions. Out of 9,000 demographic correlations that we tested, we should expect about 450 to be significant by random chance, at least at the 0.05 level. But in fact, nearly 6,000 were significant out of 9,000 that we tested. In other words, pick an issue. It is very likely that that issue is going to be correlated with a demographic dimension. Just pick one out of the hat. No theory, it's going to be it's a very good chance it'll be correlated with one of these demographic dimensions. I'll give an example. Education is highly correlated with support for animal rights. And musical preferences vary with region for almost all genre of music. So, now why is it that Southerners like country western music? Well, one possibility is that, country music is about cowboys, rap is about gangsters, and cowboys and gangsters generally don't live together. The other sort of simpler explanation, though, is that we listen to the music that our friends listen to. And we tend to be friends with people who listen to the music we like. But now let's turn to correlations between politics and lifestyle, because that's the title of the talk. Unfortunately, the general social survey that we're using does not include hot beverage preferences. So let's look at superstition instead. So who do you think is more superstitious? Democrats or Republicans? Raise your hand if you think it's Republicans. How many think it's Democrats? A few. Well, you're right. It's Republicans. Reading horoscopes? Republicans. Believe in the power of dead ancestors? Republicans. Astrology is scientific. Global warming is not, but astrology is scientific. Republicans. Had visions. Republicans. Felt in touch with a dead person. Probably someone running for office. Republicans. Now, to put this in perspective, the correlation between voting for Bush and belief in the power of dead ancestors in the 2004 election was stronger than that for voting for Bush and support for opposition to gun control. And in 2008, the correlation between horoscope reading and voting for McCain was stronger than the correlation with being a born-again Christian and with the frequency of prayer. And moreover, these effects are basically unchanged when you control for education. Well, what about the use of the internet? Using the internet for education, that's Democrats. Music, movies, Democrats. Religion, Republican. And what about the qualities we look for in a friend? Do we want our friends to be responsible? Well, we're probably Republicans. We want them to be honest? Republicans. Want them to be creative? Democrats. Want them to be intelligent? Democrats. So what is it about politics that there's these correlations with the qualities that we look for in a friend? So one possibility is that, whatever makes us value honesty versus intelligence also makes us conservative. Some demographic quality. But the between-us explanation is that people value the qualities of their friends, they tend to share their friends' opinions, and they choose friends who share their values and their opinions. So take note that we analyzed hundreds of thousands of pairwise issue correlations. And we found about half were statistically significant. So you pick any two random opinions out of the survey, about a 50-50 chance they'll be correlated. And no doubt, each of these correlations, each of these 500,000 correlations, you can come up with some sort of within-me explanation. And it would probably be somewhat plausible. But a more parsimonious, and certainly a lot less effort would be required, is an explanation in terms of between-me effects, that the correlations are generated by a self-reinforcing dynamic of homophily and influence. So now back to lattes and liberals. So Stephen Colbert would probably have a very simple explanation for why liberals drink lattes, because real men do not. So why are women, then, more liberal than men? And why is the gender gap in politics increasing over a time period when women are moving into the workforce and there's less gender differentiation in terms of roles. Well, I suspect that probably everybody in this room knows exactly the answer to this question. It's really simple. Women are liberal for the same reason that every disadvantaged group is liberal who is fighting for their rights in opposition to their discrimination that they face. So let's look at the gender gap. After we control for gender differences in support for feminism, we can use a wide range of measures, everything from equal pay to housework. And then let's see if this gender gap is still there. And indeed, it turns out that this explanation is wrong. That the gender gap has almost nothing to do with gender differences in support for women's rights. So then, what is the explanation? Well, during the same time period, there was a dramatic increase in political partisan polarization. Now, the within me explanation that you see all over the place for this increase is the increase in economic inequality during this period. So let's control for logged income, and better yet, let's control for all 8 of the demographic dimensions that we've used in these analyses. Whoa. In fact, controlling for these has the opposite effect. The upward trend is actually stronger, not weaker. A bigger increase in polarization net of the changes in inequality and any other demographic attributes that you might think are involved. And finally, let's do one last example. A within-me explanation for why social scientists like within-me explanations. So the first thing is, social scientists tend to be liberals. We drink lattes. And we like to assume that people think for themselves. And we use multivariate linear models, so we need to assume that the observations are IID. And we use random samples, so we can pretend that people have no network neighbors, because they don't have network neighbors in a random sample. But what if the independence assumption is wrong? So what if the correlations that we're trying to explain are simply one of the thousands that we can expect to observe in a world governed by the self-reinforcing dynamics of homophily and influence? If opinions are randomly clustered, the liberal preference for lattes may simply be an artifact of network autocorrelation, and the explanations that we invent are simply seeing faces in the clouds. So I'll end with that, and if there's questions, I'll be happy to take those.